Welcome to the Casted podcast here from IT University of Copenhagen in Denmark. I'm your host, my name is Tore Husfeldt. And in this podcast we talk about everything related to the foundations of information technology. Today we are happy to be joined by Toby Walsh. Toby is one of the rock stars of artificial intelligence. He's a professor at the University of New South Wales in Australia, currently on sabbatical, I think, in Berlin, at TU Berlin.
That's right.
As the author of a gazillion articles and several books, one of them upcoming. I hope we can talk about that later as well. And he, not only does he know what he talks about in artificial intelligence, he's also right now one of the most prolific popularizers of this increasingly interesting topic. So thanks a lot for joining us.
My pleasure.
So I want to eventually talk about killer robots and the apocalypse and the singularity and superintelligence and so on. But let's start with something more mundane and actually just as important for the lives of individuals, namely kidney transplants.
Yeah, it's not so mundane, but it's a really challenging problem, and it's becoming increasingly challenged, in part because our roads are getting safer. So that, for example, if I know the statistics for Australia, about 20 years ago when they first started collecting statistics, the average age of a donated organ was 32 years old. Today, the average age of a donated organ is 46 years old because there are fewer of 18-year-olds donating their organs in motorbike accidents. And so this is giving a challenge to how they decide on who gets which organ, because they have to more carefully match the age of the organ to the age of the patient, something that was ignored previously.
And this is because of increased road safety, or 18-year-olds no longer being stupid, or?
I think it's a combination of factors. They're increasing awareness, increased laws about helmet safety, and the fact that our roads are getting safer. And it's only, interesting enough, it's only going to get worse if you're a transplant surgeon. It's going to get better for us, but autonomous cars are going to reduce road fatalities down to almost zero. Sweden's campaign has a 2020 ambition of having zero road deaths. And if you look at the statistics, they're on target. There's a wonderful curve as the number of road deaths is going down, and it will hit zero around 2020. They've had all the cheap gains. That's by improving the way you design the roads, putting airbags into cars, all these things. The only way you get to the last few percentage down is by having the one loose link in the chain, which is the human driver.
So you're telling me that sooner or later the algorithmic problem of kidney matching is going to be trivialized because the number of available kidneys is going to be zero, or very, very small. But right now there's an interesting problem, or a new problem.
Well, actually the problem will be trivialized because we'll actually work out how to do either transplants out of pigs, or we'll actually work out how to use stem cell therapy to grow your own, personalized. So in about 20 or 30 years' time, the problem disappears. But in the meantime, we still have a really interesting algorithmic problem, which is how do you come up with a mechanism that fairly and efficiently matches the organs to the patients?
So that's already a lot of words which we need to unpack very, very slowly.
Yes.
So first we have this simple matching problem that we have a kidney and a patient who wants the kidney, and for reasons that have to get to do with metabolism or chemistry, things I don't really understand, not all kidneys match the host.
No, well, I mean, at the most basic level, it's blood type.
Blood type.
So you have to first of all match blood type, but it goes beyond just blood type. But you have to have a blood type match to begin with. So not everyone is compatible. And that means that there's a limited pool, but also you want to match the age now of the organs. If you put an old organ in a young person, being on dialysis is a very painful process. You would want to take any organ you can. But unfortunately, that organ will probably fail after a decade or so. Then you'll need another transplant. So that's a very poor outcome. And now, because you've had all the immune suppressant drugs, you'll be much more sensitized. Your metabolism is much more sensitized, so you'll have to have a much more precise match. So it's a very poor outcome, and you'll still need another organ. So we'll need two organs to have got you through. Equally, we could have put a young organ in an old person. The old person will die in 10 years' time because of old age or whatever, and they'll have a perfectly good functioning kidney inside them, which was a terrible waste.
Which you can't just harvest and put into somebody.
You can't just harvest. Well, it depends how they die, of course. But that's typically going to be quite a waste for society. So you're balancing this need.
So we have this already scarce resource of kidneys, that is getting scarcer and scarcer, and there are more constraints on it now, or the constraints are more visible because the number of young people donating kidneys is going down.
Yes.
So I do know, so since I'm an algorithms professor myself, I happen to know a bit about the algorithmic issue of kidney transplant, because there's a famous algorithm that I use in class to explain, and I use the kidney example to explain that. And I just recently heard a long conversation with somebody from the effective altruism community who voluntarily donates his kidney, because apparently this particular algorithm, which is due to Gil Shapley and Roth and received a Nobel Prize in economics some time ago, that builds these chains of dependencies between donors who wait. So somebody close to you has a kidney failure, needs a transplant, you're willing to volunteer your own kidney for this, but for various reasons it doesn't match. So you put your kidney in some kind of pool of, and then there's a process of kidney transplants starting as soon as somebody donates a matching kidney, and then there's a chain of subsequent kidney transplants that have to be started in some way. So that is one algorithmic aspect, which has amazing, I think, ethical implications.
Yes, so I mean, the first thing, of course, we have two kidneys, you actually only need one to live. So you can, your spouse can donate one, they can still live happily with one kidney. And you can set up, as you explained, you can set up these chains where my spouse is not compatible with me, but they can donate their kidney to someone else, they can donate to someone else, and you can form a chain, you come back to where you started, and you receive a kidney from someone else. That's been an interesting way to open up the supply of kidneys. It's a new way. We don't have to wait for people to die and donate their kidneys in a road traffic accident or die from natural causes, however. But that's made more kidneys available. But still the bulk, 95% of kidneys matched are the traditional old-fashioned way, which is one-to-one, which is just, if you like, a perfect matching in a graph of compatibility. Where you have one deceased person to die who donates typically two organs that get matched to two patients.
Rather than an individual voluntarily offering the kidney to a relative.
Yes, and then setting up these chains.
Just out of the goodness of their heart.
But what's interesting from an algorithmic perspective, in the old-fashioned matching, which is just the one-to-one matching, is that they're now having to take into account more features, for example, the age of the patient, because they didn't used to have to do that.
So, but when you say one-to-one matching, there must be several patients currently available for a single kidney that suddenly appears.
That's right, and that's why we come to this idea of fairness.
Right.
Which is that there's a long waiting list. There's thousands of people waiting for kidney transplants in Australia each year, and people die on the waiting list. They will never get to the front of the waiting list. And so there is a mechanism used to try and fairly decide who's going to get these matches. So, I mean, first of all, you look at the medical condition. You can only give the kidney to someone who's compatible. But then between the compatible patients, you have to have some mechanism that's fair to do that matching. And so that's what we're looking at. What's that mechanism? How can you do that, respecting people's ages? So
when an AI researcher says mechanism, it's a technical term. It has a very specific meaning.
So yes, I mean, it's essentially an algorithm. It's a procedure that you can run, but it's typically something that runs in a distributed fashion. And so we have a number of people coming together, all the transplant surgeons, all the hospitals, all the patients. They're putting in their information. And in this case, there is a central authority, the Organ and Tissue Authority of Australia, that's running the mechanism. It actually runs on a spreadsheet.
Right, but it's not mechanic, right? The word mechanism has a lot of connotations.
No, it's essentially an algorithm. It's essentially, and actually, interestingly enough, from an ethical perspective, the surgeons like the idea that it's an algorithm. They think, in some sense, that is fairer than a human-run procedure where they would have, you have friends, you have favors. It's not as transparent and not as clear that is as fair as a mechanism which is blind to all these things.
And more transparent?
Well, that's the thing. So we have tried to persuade them that we can come up with a more transparent, fair mechanism. But there is, the surgeons actually like the aspect that we can actually give them something where you can inspect it. You can say, well, the reason that this person was offered the organ was because they were the closest age match. They were picked fairly from the list of patients.
So this is an interesting aspect, and I believe that will come up later. So we have a way to now outsource an ethical decision to a set of rules, or an algorithm, or a mechanism, or whatever we want to call this. So in some sense, that is, of course, just a continuation of the process of governance, where we remove the strain of making individual ethical decisions from the individual to, for instance, the law, the police, the courts, and so on. And now we remove some kind of dilemma from the already stressed surgeon to another set of rules he or she can point to.
Yes, and I mean, what's interesting here is that there is some immense unsolved ethical issues here. So, I mean, probably the biggest one that I've been able to identify is this balance between individual welfare or individual utility. The fact that you want the youngest possible kidney that we can give you. If you're waiting for a kidney, you want the best possible kidney, the youngest possible one that you could have. But from a societal perspective, that's not what we want. And that's not what the surgeons want, because there's only a limited supply of kidneys to go around. And so they want to give you the organ that's matched closest to your age. So if you're an old person, you're going to get an old organ. If you're a young person, you will get a young organ. And so there's this tension. I can't give you necessarily because you're not the youngest patient on the list. People, even infants, will be given kidney transplants. You're not the youngest person, so you won't get the youngest organ, even though that's what you want. And so in making the matching, we're actually exploring this trade-off. We're balancing these two conflicting pressures between giving you the youngest organ that you want and society's need, which is to give you an organ that's closer to your age.
Fine, so this is a beautiful, tiny example of something that is going to be much more of an issue in almost everything, almost all aspects of normal life, of governance and so on, very, very soon.
Yeah, I think it's actually going to be the golden age of being a philosopher.
Yes.
And we might actually invent a new type of person, the computational philosopher, because we're having to make explicit, because we're writing algorithms, computers follow precise instructions, we have to make very precise things that we never made precise, and not precise enough that you could write an algorithm, a mechanism.
Well, utilitarians have existed before, right? But it has been armchair science where elderly gentlemen have had conversations that ultimately didn't really have an effect.
It is, but now we're actually giving computers the right to make those decisions. And we're seeing that in autonomous cars, we're seeing that here in transplant surgery. There's a program that runs on a spreadsheet that makes that decision. It comes up with a ranked list of the patients and says, this patient should be given the kidney, and that's a life-changing decision.
And you have helped with this spreadsheet, or?
So they're modifying the mechanism as we speak, and we propose a new mechanism, and I'm trying to persuade them that this is much better than the existing mechanism. So we take the old historical data and we show that given on the historical data, we could have done much better than they did.
So the result here is that you invent or describe a new mechanism which has some properties that the others didn't have,
yes.
more fair or
Yes.
more efficient, and then you can run it on the historical data and then you can show that had we used that mechanism before, then the overall wellness would have been so much better.
Yes.
So why not change?
So why not change?
Yes.
So hopefully by next year I'll be able to come back and say that's how they're now doing the 679 or so transplants they do each year.
So can you quickly sketch what kind of considerations are involved in these kinds of decision-making processes?
Well, I mean, I'm not involved in the decision making. There's a committee over.
No, I mean in the algorithm, in the mechanism.
Oh, in the mechanism itself. Well, it's trying to be fair. So there are a number of axiomatic properties. We call them axiomatic properties, mathematical properties that we try and achieve. So one of them is fairness in the sense of equal treatment of equals. So if you arrive at the same time and you have the same age as someone else, then you have an equal chance as that other person of being matched.
So there's a finite number of parameters that we stereotype the patients after, and if they're equal on all those parameters, we
Yes.
want them to be treated as equals.
Yes, but if you arrive before, of course, then perhaps you're going to have a greater chance of being matched. In fact, that's one of the properties we look for. It's a property called participation. You should be encouraged to play in the game, play the kidney matching game, which is you shouldn't be disadvantaged if you by turning up earlier than turning up later.
As a recipient.
As a recipient,
Mm-hmm.
right? So the longer you sit in the waiting list, the more chance. That's a property that our mechanism
Yes.
has. A property, and not all mechanisms will have. That you want it so that you can't game the system by strategically delaying your arrival into the marketplace of kidneys so that you get a better match later on. So if you look for a mechanism that has that property that treats equals equally and so on. And you compare mechanisms by which properties do they have. Of course, you run into, as in all of these problems in this area called social choice, is that there are these fundamental mathematical impossibilities.
Arrow's theorem.
Arrow's theorem is a fine example where you see that you can't have all of the properties together. There are some fundamental mathematical contradictions if you're responsive to people's parameters, then they can in some sense always manipulate the system by lying about what those parameters are.
And this is a phenomenon we also see in, for instance, voting theory. If you write down all the desirable properties of a voting system, then just very, very few properties are enough for you to basically have a provably unsolvable problem.
Yes, so we run into these same things in kidney matching. It's another area of social choice where you have these impossibility results that all systems will fundamentally be manipulable and you could be strategic in some sense. But at least we get a mathematical understanding of where their limitations are, where you're exposed, and what are the trade-offs that you have to play between.
So we don't just conclude that we might as well give up when we see that we formulated an impossible problem. Instead, we try to make intelligent choices about which of these internally inconsistent desirable properties we then favor over the other.
Yes, and I mean there are other strategies as well. I mean you can also say, well, we recognize the fact that this you can be strategic on this, but to be strategic you need to have full information about everyone else in the game. So maybe by keeping things secret, by not allowing people to know information about the other players in the game, then it becomes much harder for you to be strategic.
So now we have efficiency, we had fairness, there are privacy issues here.
Yes.
As there will be anywhere else. This is for insurances, for voting, for many of the decisions we are going to make.
Yes, and it's important to understand these trade-offs, and important to understand, if we are more careful with the information, then maybe it's much harder for you to be strategic, and the system can't be gamed. I mean, the reason people don't like strategic mechanisms is the feeling that someone with inside knowledge about other people playing the game can gain advantage for themselves, right? So you don't want a mechanism where people can gain advantage over others because they have inside information.
I see. Very nice. So that's kidney transplants, and that's just one example of ethically sensitive decisions being farmed out to mechanisms or decision-making procedures, which are now run, as you said, in an Excel spreadsheet, but which we can now think of as a computer.
Yes.
So a computer makes these. So help me to understand what is wrong with the following idea. The computer now makes the decisions for us.
Because we've been sold this lie by companies like Google that algorithms are unbiased. And algorithms aren't unbiased. They can have all the biases that humans have, and worse. And it's actually much more challenging these days when the algorithms include things like machine learning, and they're not what we programmed. They learn from the data that you give them. And so if you put data in that has some bias, then they can mirror all the biases that we have in the real world. So, I mean, there's a very good example of this, which was in the United States, this COMPASS program that's being used by judges in 20 of the 52 states of the United States to help them make decisions about when to release people on parole. And that was shown to be racially biased. That it wasn't intended to be that way. I mean, I don't suppose the programmers who wrote the program wanted it to be racially biased. But it was trained on data. It was because it had machine learning, and it was trained on data that had implicit biases. And so it was more likely to predict that black people would be reoffend than they would, and it was more likely to predict that white people would not reoffend when they will. And so black people were being locked up because of a bias in an algorithm.
Because the decision for the length of incarceration is, as far as I understand, correctly informed by the probability of a reoffense.
Yes.
And then the data for making that decision is then correctly or incorrectly inferred from a machine learning algorithm that is trained on old data. So this is this reinforcing mechanism that just makes bias worse and worse as we algorithmicizes.
Yes.
Is that a word? Yes. So to read up on that, I think the recent book, what is it called? Weapons of Math Destruction, I think, has a chapter on that.
Yes.
There are probably many other places to read up on that.
And one of the challenges, I mean, an interesting one from a computer science perspective, is that the sorts of algorithms we have today, most of the algorithms we have today are black boxes. They don't explain why they came up with these particular decisions. And so, we have to worry about, can we trust them? And so there's an increasing area of research, people thinking about, well, how can we come up with algorithms that can explain, that can, or how can we come up with algorithms that can come with guarantees?
So when you say most of the algorithms are black boxes, we're referring to the recent immensely successful family of algorithms that we can absorb under machine learning or neural nets, learning algorithms.
Yes.
Rather than, for instance, what I teach, which are very, very transparent, strict, where basically you understand every line of code and what it does, and you've proved its properties and analyzed its efficiency. So this is a sad situation we're in right now. That the most powerful decision-making procedures that are most efficient and very, very impressive in what they can do are also those that we have very little operational understanding of what's actually going on.
Yeah, we have very few formal guarantees of their properties, and we have very limited insight of limited ability of them to explain why they make particular actions.
Yes. As a mathematician, I'm mortified and personally insulted by the fact that the stuff that we don't right now understand actually happens to work pretty well. But that's just an aesthetic choice, right? That there's actually a social argument for being just as concerned about this.
Yeah, I think society is waking up to some of these issues. I mean, the Compass with this judicial example, I think, was a good wake-up call. We're starting to realize that we are giving decisions to some complex algorithms, not the ones that you were talking about, but that do have immense consequences on our society. And we should be very careful about doing that, because we will be giving up some hard-fought rights about racial discrimination, sexual discrimination, all these things that we fought for the last 50 years. We may give up because we give algorithms that we don't have promises, we don't have guarantees on the rights to make those decisions.
Does it make a difference for this argument whether this discrimination is quote-unquote correct? There are two sources, there are two reasons to be worried about this or angry about it or generate some kind of social indignation. And one would be if the predictions or generalizations or the stereotypes that are the result of these learning algorithms are actually factually incorrect, and then we make decisions that are not only morally questionable but also factually wrong. But then there's the other argument that many of these inferences could actually be correct, but aren't we in some sense in the same situation then? Is there a way to unpack this?
There is. I mean, I think if they're incorrect inferences, then we should be outraged.
Yes.
Society would be rightly outraged.
That's the easy part, yes.
But there's a more deep, fundamental philosophical question, and this is a societal question, not a technical question, which is, should we be necessarily outsourcing all of those decisions to machines? Locking up, incarcerating people is probably one of the most severe decisions we make as a society, taking away people's liberty, and something that we shouldn't do lightly. I'm not sure that I would want to wake up in a world where we've outsourced that completely to machines.
But you are in a world where we've outsourced this decision to the legal system, which in some sense is also just a very old-fashioned algorithm of rules and regulations that have that interact with each other in a complex way, and where exactly we have outsourced possibly individual decision that was made by King Arthur in the olden days. Now we've moved that to a decision-making process that is no longer in the brain of a single human, but has been a social process. So there are these rules. So where is the qualitative difference between outsourcing the ethical question to a set of rules such as a law, the tax code or the penal system, and outsourcing it to an algorithm that runs somewhere in a server in Silicon Valley?
That's a great philosophical question, I think. But if I think you look in most countries, the most severe decisions we make in criminal trials, they're typically in front of a jury. That we outsource our most challenging decisions to a jury of our peers, and we respect their ability to make a decision, judged by I think it comes down to our humanity at the end of the day. Those in really important critical decisions, life-changing decisions, we say it's a jury of your peers make that choice. And I'm not sure we all want to wake up in a world where we say, well, it's because the machine said so.
No.
Even if the machine, as it could be, if it was properly trained, it has all the algorithmic guarantees that you want, could actually make a better decision than a human or a jury of our peers.
So I would at least be able to say the machine did so because in line 457 I'm comparing this variable to that variable, and then with reference to the rule that we all agreed on in an electoral process, that is the proper rule to use. But currently I can't do that because currently there's just some bloody neuron in an artificial neural network that seems to fire, and sometimes it does and sometimes it doesn't. So it's the lack of transparency currently that gives us an added ethical problem that we didn't have or don't have with the legal system.
Yes, yeah, I think that's very much the case. And there are fundamental issues about liability. So an autonomous car is going to kill a pedestrian probably in the next 12 months.
Yes, they just I think there are already 2 deaths in 2016.
Joshua Brown was killed in May last year, and a Chinese person was killed in Macau, I think it was.
So
they were drivers. They'd signed up.
They were drivers.
Drivers.
Yes.
They were sitting in the passengers,
yes,
in the driver's seat, not driving.
Yes, yes.
But they had at least clicked the buttons.
They bought the Tesla and yes,
and clicked the button saying, "I agree to the operating rules of the Tesla motor." So it's legal sense that maybe Tesla gets away with that one, but in very short time, in 12 months or so, someone's going to be a pedestrian or a cyclist is going to be hit by an autonomous car. Just the laws of numbers,
yes,
large numbers is going to happen. And because we share the roads and the technology is still under development. That's an interesting ethical question as to whether we should really be trialing the technology on public roads. And then people are going to start saying, well, who's liable? Is it the owner of the vehicle? The owner of the vehicle may not be sitting in the vehicle. It may be someone else who is actually operating the vehicle. Is it the operator of the vehicle? But they didn't write the code. They're not, in some sense, responsible for the errors in the algorithms that are causing that accident to happen. Is it Tesla, or is it the software engineer who wrote the code? But they wrote code that was then trained on data. Was it the person who put the wrong data in there, or not enough data? There's just so many interesting questions there.
So now we're getting to one of my favorite topics of adolescent philosopher, namely trolley problems.
Yes.
So this is basically, we will see decisions that are basically trolley problems being made on the road within the next year or two.
They are. It's interesting to realise that we've been solving the trolley problem for 100 odd years. The 100 odd years that we've been driving cars.
Yes.
But in the past, and this goes to the algorithmic questions we were talking about earlier, in the past, if you had a trolley problem, you're driving along the road and someone steps out into the road, do you run them over? Do you drive into the curb and possibly kill yourself? If you made the wrong decision, you survived the accident, and it was considered that you behaved in a way that was potentially, you did the wrong thing, then you could find yourself in a court and you could be prosecuted and you would have to face the consequences of your actions. But today, we're actually going to have to decide up front, because we've got to write programs as to what
yes,
they're going to do.
Yes.
And so that's why we're having to make precise, our decisions, our value judgments. Well, the code that comes to this point is identified a pedestrian in the path of the car. It's now going to make a decision. We have to weight these things up in our code.
And so far, people have been able to push. So trolley problems seem to be psychologically stressful for people because it clearly pitches your immediate Arethian ethics, the good old-fashioned ethics of basically doing what feels right in your gut against the rational utilitarian ethics, and that seems to be something that we simply don't like doing. So most people will find excuses to not think about this issue and just reject trolley problems as as a stupid problem. And even if you say, what would you do if you're in that situation? You can always say, I will never be in that situation. Likewise, I will never, when I drive my car, be in the situation of having to make an intelligent choice whether I should run over the 14-year-old heroin addict or the 81-year-old nice old lady. And so the probability of being in that situation is simply zero. However, the probability of somebody writing the code for what the Tesla should do in this situation is 1.
Yes.
Somebody is going to write that code, and they probably already did it, and presumably they didn't. I assume this is machine learned. I'm not sure.
That's an interesting question. So if you look at a company like Tesla, yes, it is machine learning. So in some sense, they're saved from having to solve this problem. I mean, I talked to some of the people writing autonomous software, and they say, well, we don't think about trolley problems because it's just they're writing machine learning, and there's not one line in the code,
yes,
and there's no one to blame in that sense for that reason, because it's something that will be some learned behavior. But
I want different countries to produce cars that are well aligned with their philosophical traditions. So this would be a new British motor companies could actually. I would buy the Hume or Locke car that
Well, you
that
might
uses
want to
those.
move to Singapore then, because in Singapore there's a different trial. I can't remember the name of the company, but there actually the top level of the software is some fuzzy logic.
Oh,
So that they can actually have explicit rules.
yes.
They're fuzzy rules because they recognise the fact that actually it's not driving, as we realised, driving a car is actually full of exceptions and actually violating the rules. You actually have to exceed the speed limit to overtake someone. You have to cross the white line to overtake someone. So you're always violating the rules, so that they're fuzzy rules that they apply. But they're interestingly enough, so that they can actually work out when it makes mistakes, they can go back and say, well, we didn't have a rule for this. Let's put in a fuzzy rule for this, so it won't ever do that again. So they have much more, in some sense, guarantees in the behaviors, because there's a layer of logic at the top. It's not just all learned behavior.
So consumers seem to all agree that cars should maximize social welfare, except their own car, right? Their own car, they want the Opel Nietzsche or whatever it would be called. Or the Ayn Rand model that maximizes the probability of the driver surviving.
Yeah, well, we're back to kidney matching here again, and it's a trade-off between individual welfare and social welfare of the community as a whole. Yes. And we're discovering that writing autonomous software for cars is like writing the kidney matching software. We're making a trade-off between these things, and maybe we as individuals shouldn't be allowed to make those choices. Maybe it should be that society, your country or whatever, makes a decision as to what our values are as a society.
I would be surprised if we sort of found the right answer to this in this conversation, because already the question of whether the nation should then favor its own citizens, which seems to be both obviously correct and also obviously perverse, is a difficult question.
It is, but this is why it's going to be a golden age for philosophers, computational philosophers, because if we're going to give responsibility, autonomy to cars to drive on the roads, to algorithms to decide who to match kidneys, then we have to come up with we have to solve these really challenging ethical questions.
Well, they will be solved, right? The question, a decision will be made.
One way or the other.
A decision will be made. The question is how much will we be able to influence this, and how fast will we be able to make this a sufficiently important topic so that governance or whatever body is going to. You said in Australia there's a tissue.
Organ and Tissue Authority.
The Organ and Tissue Authority.
Yes.
Amazing that it makes these decisions. So we will have a trolley problem authority. Oh yes, if there is an opening, I would really like that job. A trolley problem authority to make these decisions. So this is a real AI worry. This is something that is relatively new. It has to do with artificial intelligence and it's artificial intelligence in a very narrow sense. It's basically just algorithms that make decisions, so we confuse these decisions with intelligence, or maybe they are intelligence, but we use the term artificial intelligence to describe a specific class of algorithms that are somewhat distributed, somewhat multifaceted. Sometimes they are machine learned, and they also seem to be important. No, artificial intelligence can do unimportant things in video games as well.
Well, there's very little AI in video games. It's mostly a marketing slogan that's added to the box. But you're right. I mean, there's a dozen trials around the world of autonomous cars, taxis, and buses and trucks going on today. And in 5 years' time, autonomous vehicles will be routinely sold. So we have to solve these problems. And they're questions for society, not just questions for technologists like you and I. We're going to have to implement what society wants. We have to make these decisions because you'll be getting into an autonomous taxi very soon.
Yes.
And that will be making those sorts of decisions.
The challenge then is, I think, clear thinking about these issues, clear thinking about what AI is and what it isn't.
It's also about not being distracted by fears of superintelligence.
That's where I wanted to go, because these are real worries about AI. I think there's another one which I also like to talk about, but yeah, we haven't mentioned the Terminator scenario at all yet. So let's go there. What's wrong with the following argument? So we saw this moderately intelligent decision-making process about say kidney matchings or real-life trolley problems in the Tesla. Clearly, if we assume the materialist model of the human brain, that this is just a computational process, and there's no magic involved in my brain, I'm quite sure about that, it's just completely material. I think this is called functionalism sometimes. So that is some kind of cognitive process which ultimately can be explained just in terms of rules. Deterministic rules even, maybe there may be quantum effects, I don't know. So that's observation one. Observation two is that computational power, no matter how pessimistic you are, computational power is clearly growing. If you compare a computer from, say, Turing's time with today, we can do amazing things like Microsoft Word or Angry Birds on computers. So this is clearly growing. So it's not, so obviously then, sooner or later, computational power must catch up with and then quickly surpass certainly my intelligence, human intelligence. It's not a question of if this will happen, but only when this will happen. And then futurists all over the world seem to advocate dates. The last thing I read just yesterday is that it's going to be 2029.
Yes, Ray Kurzweil's latest prediction.
Yes, that's from yesterday only. What's wrong with that argument?
Well, I mean, there are a number of things that are wrong with the argument. First of all, Moore's law is dead. Officially, Intel have declared Moore's law is dead. So,
but I don't need Moore's law. I just need a brilliant algorithmic theorist like myself who invent cleverer and cleverer algorithms all the time. After that, that's what society pays me for. So I don't need Moore's law because I will just get smarter, better and better ideas.
So the next thing to be concerned about, next assumption to be concerned about is this idea of recursive self-improvement. So a lot of people's concerns are based upon this snowballing idea that we'll get to this singularity, this point, this tipping point where the machines are suddenly so intelligent, more intelligent than us, that they can redesign themselves, and then those new machines redesign themselves, and this is the beginning of an exponential growth, and then everything's, then we wake up the next morning, we're no longer the smartest things on the planet, and we're now taken over by the machines. Well, we don't know how to build machines that can self-improve, and nothing we've ever built is anything that can self-improve.
But I read that all the time. I read all the time about machines that now program themselves, that learn stuff.
They learn to do a particular task better and better and better, but only that task, and they don't learn to learn any better. So that, AlphaGo learned how to play Go. It learned to play Go. I mean, interesting comparison actually between humans and machines there. It learned to play Go by playing billions and billions of games of Go. In fact, if you started playing Go the moment you were born and only ever played Go the whole of your life, that's the only thing you ever did, you wouldn't come close to that number of games of Go. Right? So actually AlphaGo is a very slow learner. And interesting enough, so in the match that they played against Lee Sedol, one of the world's best players of Go, as most people know, Lee Sedol lost 4-1, which was a great upset to the Go world. Some Go masters said we would never get there. It's a very, very un-machine-like, very human game that required lots of intuition that humans would always have an advantage over machines. And so it was, quite an upset that we had got to this. It was a landmark moment where people had said it would take a long time or even ever. But interestingly, Lee Sedol played 3 games of Go against AlphaGo, and AlphaGo was playing a new type of Go. They played moves, especially at the beginning of the game, that Go masters in thousands of years of playing the game of Go had never seen. And actually, the Go masters are quite excited that this is going to open up new ideas about the game and give us a new understanding about the game of Go, just as chess programs have opened up the game of chess to us in the last 20 years and changed the way we play chess. So they're thinking that this will open up the way we play Go. So AlphaGo was playing a new type of Go, and yet it took Lee Sedol only 3 games of Go to learn this new style of Go that he won the 4th match. And so that was actually a great victory for humankind. I'll claim credit for Lee Sedol here, that we are immensely quick learners. It didn't take Lee Sedol billions of games of Go to learn a new type of Go. It took him 3 games of Go.
I think the entire thing is a huge plus for humankind. The fact that we as humans can build Go machines that are this good, or poker computers that are this good, is actually great. This is a testament to human ingenuity and not to the fact that we are slowly losing against the robots.
It is. And people would say, well, they were somewhat surprised. The person, the Frenchman who had written the Crazy Stone, the best Go program before AlphaGo, had said a year before, it would take 10 years before we get close to being able to play a Grandmaster level. Mm-hmm. And it took less than 24 months. But Google threw vast amounts of resources at it, 10 times the resources that have been thrown at the problem than almost any other project had thrown at this before, and their vast server farm. So in some sense it was more a Manhattan-like project, in the sense if you throw enough resources, you pick another narrow enough domain, and this is what's happened in many areas of AI, then we do manage to succeed. And so in some sense it was a testament to...
So to help me to think about it, I like the phrase narrow enough domain. So if we have I think that's a von Neumann quote. As soon as you give me a precise enough task and describe well enough what you want the computer to do, then I can basically sit down and make the computer do exactly that. So the success of some artificial intelligence is an artifact of the narrowness of the task that has been specified. And then we can throw just enough data or computational power after it and 2 or 3 clever ideas, and then we will solve this. But why does not this argument, with which I agree, why does not this extend then to say, right, but the difference between me and many narrow tasks is just a question of scale. You can break me down into 100,000 narrow tasks, so we just need 100,000 AlphaGos, and then the thing will suddenly become sentient because there's a qualitative shift between 100,000 narrow tasks and the amazing intelligence that is my brain.
Well, so there's a whole bunch of different things. You raised that delicate word, sentient, just now, and moving into consciousness. We don't know whether intelligence is a capability at 100,000 tasks or 10,000 tasks or a million different tasks. But one thing we do know is that we've only built systems that are idiot savants. They can solve a very narrow focused domain, and they have no ability to move outside that domain. If you took AlphaGo, it couldn't play chess. Even though the rules of chess are not that much different to the rules of Go. In fact, if you told AlphaGo we're going to play a new type of Go where the idea is to lose as much territory as possible, not to gain as much territory, it would have no chance.
Because there's not a vast library of previous Go games that it can train itself on.
No, it would have to start again. Whereas you could take a Go master and say, we're playing a new type of Go, you have to lose territory rather than gain, and they would probably be quite good at it. Or you could take a chess master and say, the idea is to lose as quick, it's kamikaze chess, you lose as quickly as possible. They'd be very good at kamikaze chess.
So let me try a last attempt at pushing back against this then.
Yes.
What about those results where, I think it's Google, I'm not sure, have made an AI play all 8-bit Atari video games or something like that in no time, without telling it what the goal is? Just plug in the machine into a video arcade and it comes out winning Pac-Man and Space Invaders and Tron.
Well, you're right. People were impressed that they were able to use one algorithm that learned 40-odd different Atari video games. And so that was interesting. That was one machine learning algorithm. But each time it learned separately. It had to be trained on each of the games. Although there's some recent work they've been doing called transfer learning, where they're trying to transfer abilities between the games. But they were very narrow, focused domains in each case. And, for example, it wasn't very good at Pac-Man, or Miss Pac-Man it was, because it required planning. You had to think, when am I going to kill the ghosts? Eat the cherry so that I can eat the ghost. And you have to plan your route around the ghost. And that requires some think ahead, whereas the games that it played well were the ones which were just pure reflex games where you have to get out of the way of the bullets or get in the path of the ball. And so perhaps it wasn't so surprising that a similar algorithm could learn each time. But it was an impressive result, but still a very artificial world away from the complexities of the real world. If I take you and I throw you into a new situation, I drop you into Japan or China or somewhere, you'll find your way around, you'll work things out, you'll learn a new language, you'll cope. I mean, that's the amazing thing about the human brain, is how adaptable it is. And we don't build systems that have that breadth of ability by far. We build things that are focused on very narrow domains. And the problem is that people say, well, they see it playing Go and they think, well, I can't play Go. Therefore, it's only a matter of time before it's going to take over the planet. Whereas all it's ever going to do is play Go. It's written its code. It will never do anything other than play Go.
So worrying about superintelligence is the wrong thing to worry about with respect to artificial intelligence.
Well, Andrew Ning likes to say it's like worrying about overpopulation on Mars.
Yes.
At some point, maybe we will have to worry about it. It's not something. You can never say never in science. I mean,
so I actually I like the quote, and I like to sort of take that one step up and say it's like worrying about overpopulation on the Sun, because I do understand that populating Mars is just a quantitative step away from populating Luna, the Moon, and at least we've been there. So this is sort of populating Mars, I can see, is just an extrapolation of techniques we have learned, building rockets and maybe building artificial environments on cold rocks that are hurtled through space. So I can sort of see that there could be a Mars colony because that's an extrapolation of what we're already doing. But having a colony on the Sun seems to be a qualitatively different thing. I can't see, so from where I'm standing, superintelligence is not an extrapolation of our current techniques in artificial intelligence. I think we're making amazing progress, but we're certainly not driving in the direction at the end of which is my brain. Because my brain doesn't seem to work like that at all. The ways we build artificial intelligences seem to be kludges and tricks.
Well, we shouldn't put ourselves on a pedestal. I mean, the history of science is one of where whenever we thought we were rather special, and our biology is full of lots of kludges, there's no reason that evolution got a very well-engineered thing out of it. I mean, the evolution never invented the wheel, which of course is the most efficient way to travel, right? And we get around because we invented the wheel. We get around much more efficiently because we engineer much better solutions. And so I don't suppose that when we build artificial intelligence, it will be the same as ours in any respects at all.
But that's what I mean. The direction we're going in with AI does not, for me, seem to have anything that is like an anthropomorphic mode of reasoning. No,
and a good example I like to give to people is aircraft. If we try to build aircraft by looking at nature and looking at one example we have of birds and insects that fly in the world, we would still be standing at the end of the runway flapping our arms trying to fly. We've discovered a completely different engineering solution to the problem, where we have a fixed wing and a very large, powerful engine, a jet engine these days, that powers us down the runway. It comes back to the same fundamental laws of aerodynamics that put the plane into the sky just like the bird, but we still don't understand feathers that well. We still don't understand how birds miraculously fly with so little energy. But we wouldn't be jetting around the world if we'd gone to try and replicate what nature does. But there's the same fundamental laws behind those birds as behind the planes. And so one reason why I was excited to go and work in AI as a young boy was the thought of that actually it gives us insight into these fundamental questions about the nature of intelligence, and that may actually reflect back on our understanding of ourselves, even if they're different engineering solutions to the problem.
Are there examples of that? Are there points in... I attended a conference on computational neuroanatomy, which was way above my head, but just told me that basically nothing I'd learned in my neural networks class when I was an undergraduate had anything to do with what's actually going on in the brain, because neurons in the brain, real biological neurons, seem to be crazy.
Yes, the limited I know about neurology is that our computational models, the neural networks, we're rather abusing the words neural network to be comparing them as to the amazing things that are going on in our brains. We have no understanding really of what's going on, and there are these human brain brain projects to try and map the brain and give us greater understanding. But the human brain, is the most complex system in the universe that we know of by orders of magnitude. There's nothing that approaches the billions of neurons, the trillions of connections that are in the brain. It is of a complexity beyond anything that we have any understanding of. So it's going to take us a long time to understand that, and our computational models are poor, immensely poor in comparison to what really is going on in the human brain. But that doesn't mean they can't do interesting things, and it doesn't mean that they can't give us insights as to what is the nature of intelligent thought, and or build systems that are useful, at a very practical level.
So let's leave superintelligence then and go back to what AI is actually doing and what we should worry about.
It's very good to leave superintelligence because I think it's a distraction from things that are much more pressing.
Thank you very much. I think it's the wrong thing to worry about.
And
right
actually,
now.
I say to people mostly it's stupid AI we should be worrying about, that we're giving responsibility to machines that have such limited intelligence and shouldn't be given those responsibilities.
Stupid AI as in the cars?
As in the cars, yes. The Tesla that killed Joshua Brown didn't see the truck turning across the road, whereas a human would have seen it.
Oh, so it's stupid. So we should worry about stupid AI qua its stupidity rather than worrying about superintelligence because it's so very, very much smarter than we are.
Well, unfortunately, as humans, we're very quick to give responsibility and to sit back and let machines take over, thinking they're much more capable than they are. It's a common human failing that we'll see a system behaving well 90% of the time and think, oh, well, it's fine, but actually 5% of the time we'll have to step in and take back the steering control.
So what's some other area into which we are currently farming out decision-making processes to autonomous agents and that we should worry about?
We already mentioned the sentencing decisions. We already
yes.
They're being increasingly used by governments to decide social welfare payments. There's been a big controversy recently about that in Australia.
Insurances, I guess.
Insurance, almost every aspect of our lives, we're discovering that we're giving over responsibility. Every time you're using Google, there's some AI behind, what search results it offers you and the biases, all the controversy we have these days about fake news in Facebook.
But that part I'm sort of okay with, right? If I go into a news agent and just take the newspaper I like, instead of having Google sort of determine what I like.
But most people are getting their news out of Facebook,
yes,
the news feed, and that's an algorithm that's deciding what they see. And some of that is not news, some of that is fake, and some of that is also, even if when it is real news, there's still a bias as to what it's showing you. And is it just confirming your own biases?
I've been evangelizing about that issue for many years now, since this entire filter bubble controversy. And it seems to me that this is an issue that people are intensely aware of, I guess thanks to journalists. So this was something that was really easy to talk about and get and spread through normal channels of media, because journalists suddenly became very concerned about filter bubbles and these self-replicating echo chambers and so on. So I give this lecture now and then to the general public, and they seem to be very aware about these effects.
They are, but I suspect in the United States we're witnessing the experiment gone wrong. The president that they have in the United States is a consequence in part of these filter bubbles. There's groups of people whose news is completely different to the news that you might read in the liberal press.
Yes, but the alternative then would be some kind of truth ministry that forces everybody else to read The Guardian.
No,
and not only for the crossword, which is where I am there, but so I think this is worrisome, but I think it's orders of magnitude better known than having societal decisions like sentencing or insurance or benefits.
Your health insurance rate, your car insurance rate, that's decided by an algorithm with postcode biases, with social biases that we are not aware of.
It's much more subjective than it was before.
Yes.
It's much more personalized, which may be a good thing or a bad thing, but it's something worth talking about.
Interesting enough, Europe is ahead of the curve here. There's this new European directive that's coming out that's asking for explanations to be provided for when algorithms are making decisions about you. It's not clear what that means or how that's ever going to be implemented, but at least there's the feeling here in Europe that people are much more aware of the issue and starting to think about, well, how can we try and legislate around this to make sure that as a society people are treated fairly. And I think it goes to a fundamental problem sweeping democracy today, which is this increasing inequality within society and a feeling that not everyone is being treated fairly anymore. And algorithms can be used to amplify some of these problems.
So can the law, but we are currently in a the problem might be that right now we are sort of inclined to trust the algorithm more than we trust the policeman.
We are.
That's the problem.
We are, and we've been sold this complete lie by companies like Facebook and Google that the algorithms are unbiased. They're as biased as the person writing them or as the data they're trained on. They can have as many biases as humans, and they can even be worse if they don't have any guarantees or explanations. Then they're complete black boxes to us, and so I'm very fearful that some of these rights will be lost because we won't even be able to understand why they made those decisions anymore.
Mm-hmm. Thank you for saying this. I completely agree on these issues. So can we end with, so we avoided one Terminator scenario.
Yes.
Namely the Arnold Schwarzenegger-like autonomous sentient machine that makes its own decisions and is an artificial superintelligence. But those are not the only Terminator robots we need to worry about. No,
they're not, unfortunately. And I've become rather, I guess, an accidental activist in this space, in the sense that the last couple of years I've become more and more politically active in some sense, more than just my scientist hat, in the discussion around autonomous weapons, or as the media like to call them, killer robots. And here the fear is not, as you say, it's not the Arnold Schwarzenegger Terminator sentient robot. It's actually stupid robots. It's the sorts of things that actually are technically quite near.
The one in the RoboCop movie from the 80s, there was a stupid Guardian robot that just shot people without being very smart about it.
Well, and we have something close to that today. Samsung, the nice people who make mobile phones, also have a company that builds a sentry robot. It sits on the demilitarized zone between North and South Korea. It's got radar and computer vision. It will shoot you with deadly accuracy from 4 kilometers away if you step into the DMZ, completely autonomously.
So this is just a step up from, say, the wall between the two Germanys in the Cold War. There were also more or less automatic weapons that shot you when you moved.
Well, we've had autonomous weapons since almost the last 100 years. I mean, a landmine is a completely autonomous weapon. Yes. Sea mines. In fact, interesting enough, some of the first arms legislation was introduced because they were worried about people just throwing mines into the sea mindlessly and the effect that would have on the world. So yes, we have drones flying above the skies. Those are still semi-autonomous. Most of the decisions are still made by a human back in a container who's flying the thing. But it's a very small technical leap to take the human out of the loop, replace them with a computer. In fact, most people think that's technically possible today. UK's Ministry of Defence say that they think it's technically possible today. They could fly an autonomous drone. They actually have a demonstrator, the Transit drone, that will fly across oceans completely autonomously, will make targeted decisions completely autonomously. And that, myself and lots of other people think, will be a very dangerous step. In fact, it's been called the third revolution in warfare. The first revolution.
So talk a bit more about that and explain to me what is the difference between being killed by an autonomous drone and a drone where there's a human at the other end.
When there's a human at the other end, there's a human who makes that final life or death decision, who says, looks at the ground, makes awareness of the situation, what's going on, sees how it's changed since the drone took off, and makes that life or death decision. An autonomous drone, that would be left to an algorithm. It would make the targeting, tracking, and ultimately kill decision itself. And
decision might be better or worse.
It might be better or worse. I mean, so when I talk about these sorts of issues, people think there's sort of one set of arguments that applies at all time. And I like to point out, actually, no, my objections today are different to the ones that will be in 20 years' time, when the algorithms are probably going to be more effective, possibly even more ethical than humans. And so in 20 years' time, I can imagine that we will have better computer vision systems, better situational awareness decisions, that we could give that over to a machine, and a machine would make a more accurate decision.
That makes a more correct decision about whom to terminate.
And then my concerns about autonomy in the battlefield are different ones than the ones I have today. My concerns today are that we don't know how to build those. We don't have systems with that accuracy. The drone papers that were leaked in November last year showed that 9 out of 10 of the people being killed by the semi-autonomous drones today were the wrong people. As a computer scientist, I would aspire to get to 9 out of 10 mistakes as but my target error rate would be.
Yes.
I know I wouldn't get there today. So we'll be making huge numbers of mistakes, collateral damage.
But even if we had an error-free system, then the accountability problem would still be the same.
So a bunch of different issues then come up. One is accountability. Another is that it will put us in a situation where war is too easy. The triggers to war will happen too quickly. We already have this in the stock market. We have flash crashes where the system is unstable because it makes decisions too fast. And so it will be changing the decision rate into which you go into battle. They would be terribly destabilizing in terms of the geopolitical order. So at the moment, your military might is determined by your economic might. You are a superpower because you can raise a large army.
But it is to a large extent determined by an economic might right now, but there's still the liberal democracies have this problem of being very unwilling to sacrifice their own humans.
They are.
Right now.
But that
and
will
if you take that away,
if you completely change that. So first of all, any tin pot dictator can buy themselves an army of autonomous drones or autonomous tanks. Previously, to control a civilian population, you had to persuade some people to follow your ends. Now
you're a dictator, that's not a problem. But
now you would just need one programmer who could program 1,000 robots for you. So the current, geopolitical order, which is already reasonably unstable, will be destabilized even further. The barriers to war would drop significantly because you would be able to go to war without fearing you'd have body bags coming home.
And these are small-scale conflicts.
The triggers to war would be much lowered because we'd have, again, complex systems interacting. We don't know how they're going to, feedback loops that might happen between them. So this all sounds very bad to me. As a
yes.
computer scientist, I'm terrified by all these prospects, which is why in July in 2015, I got 1,000 of my colleagues to sign an open letter saying, there's an arms race happening, we can see it already today. We should think very carefully, we should think about whether we should, as we have with other technologies, nuclear weapons, chemical weapons, biological weapons, blinding lasers, anti-personnel mines.
Yes.
We've occasionally decided the world would be a better place not to have this technology in the battlefield. Let's use it for all the good things, autonomous cars.
Yes.
250 people will die on the roads of Denmark in the next year. Once we have autonomous cars, that number will go down to 0. So let's use the technology for good things, not for bad ends.
Good. Great. So currently we have this problem of actually not even being able to reason or think clearly about these issues because, for instance, the autonomous robot scenario is being muddled by these visions of post-singularity artificial intelligences that take over the planet and want to rule us.
It is, but also you can see the beginnings of an arms race.
Yes.
And people ask me, well, where is it happening? Well, it's happening in all the obvious places. I mean, the US DoD has $18 billion in its current budget to build the next generation of weapon systems, most of which are going to be autonomous. $18 billion buys you a lot of weapons, a lot of weapon development. China is investing heavily in this space. Russia is investing heavily in this space. Israel is investing heavily in this space. The UK is investing heavily in this space. All the obvious people are, and there's an arms race going on, and you can't blame them. And, people say, well, people say, what's going on in China? So it's very hard to know what's going on in China because it's China. But you can see the videos of what's going on in the US. If I was the Chinese, I would be investing heavily in this space because I know the only way to protect yourself against an autonomous weapon, to have the speed of reflex, to have the accuracy, the ability to work 24/7, to go into the most dangerous places without any risk, is to build yourself autonomous weapons like the US are developing. So it's not surprising there's an arms race going on.
Yes, and as a computer scientist, of course, the idea of having a distributed system of probably networked machines talking to each other is a whole different kettle of fish already, just from a computer security point of view.
It is.
They would like to take over those machines.
It is. But we don't, occasionally we make a decision as a society that we'd better not to go down those roads. It would be better not to have biological weapons or chemical weapons. And arms controls are not 100% effective. We have had, in Syria today, you will see some use of chemical weapons. But nevertheless, there's probably a lot less use of chemical weapons because of the treaties against chemical weapons than if we didn't have them. And so my hope is that if we could get some treaty against the use of autonomous weapons, that would limit to a large extent their use. It would certainly limit arms companies from developing them. And if arms companies are not developing them, they won't be sold on the black market. It will be much harder to get your hands on.
And that's
the
a more
technology.
precise plan than saying, let's prevent ourselves from developing a better and better AI.
We're not going to stop that.
No.
In fact, we want that. Our autonomous cars have much of the same technology. I like to point out to people, it's one line of code you change to turn an autonomous car which avoids pedestrians to one that targets pedestrians, right? And immediately you've got yourself a terrorist weapon, right? And that's
right.
Terrorists will do that at some point in the future.
And there's reason to be moderately optimistic about us agreeing on rules against autonomous weapons, because we have done similar things with biochemical weapons, for instance.
We have. I mean, it's a more challenging space because, if we compare it to, say, nuclear weapons, where we've been reasonably effective at stopping their proliferation, the nuclear weapons require a lot of money. They require access to fissile material. They require the resources pretty much of a nation state to be able to develop one.
But this you can do in your kitchen.
But equally, I like to point out to people, chemical weapons you could do in your kitchen. It doesn't require a degree even in chemistry to build yourself a chemical weapon. It just requires some chlorine.
Don't try this at home. This man is a trained professional. Right. Toby, I think we've covered everything I wanted to talk about. If one wants to read up on this, you maintain a very informative blog with lots of good thinking about AI called The Future of AI.
.blogspot.com.
It's at blogspot.com. And there's a book coming out?
There is, yes. I guess first time I've get to plug my book. So it's called, in the UK, it's called Android Dreams, the Past, Present and Future of Artificial Intelligence. And in Australia and in some other parts of the world, it's going to be called It's Alive, From the Logic Piano to Killer Robots. And
there's an Arthur C. Clarke reference in the English title.
Yes.
And It's Alive is just a generic B-movie from the 50s reference.
And there'll be a Chinese, I saw the Chinese rights as well, so there'll be a Chinese version. I don't know yet what the title is in China.
So Android Dreams?
Android Dreams, yes. You can pre-order it on Amazon already.
I will. Thank you very much for coming, Toby.
My pleasure.
And thank you for tuning in. Bye.